Hello everyone, in this video I'm going to explain how to graphically plot lines and identify intersection of lines. Okay, so here is our task. First, I want to plot this equation, second and another equation, and third I want to identify their intersection. First of all, when you see this kind of expressions, this kind of equalities, it represents a line. So how do you see that? Well, you see there are two variables, x and y, and they both raised to power of 1. Okay, they all raised to power of 1. That's why there's nothing over here. Okay, so when you have two variables with power of 1 and equality, that's a description of a line. So any points with the coordinate x and y that satisfy this equation, they fall in the same line. So how do you graphically plot a line like this? It's quite simple. All you need to do is to identify 2 points on this line and connect them. So let's start with the first task. All I need to do is to find 2 points on this line and connect those points. Okay, so how do I find a point on this line? It's quite simple. You assign a value to either x or y. You basically, theoretically, you can arbitrarily pick a value and assign it to x or y and then solve for the other one. For example, I'm going to set x equal to 0. Again, this is an arbitrary choice. I choose to set x equal to 0. You can choose x to be 1, 2, 3, whatever, or you choose y to be whatever and solve for x. The same thing. Okay, so I set x to 0 because it's easier to calculate. I plug this into this equation. So 2 times 0 plus 5y equal to 20. So which means 5y equal to 20. And this is equivalent to y equal to 4. So I have a point called 0, 4, which is on this line. So I have identified a point on this line. Now let me find another point. Now this time I'm going to set y equal to 0. Again, why do I choose y? Well, it's kind of arbitrary. You can choose x. Why do I choose 0? Well, again, this is arbitrary. You can choose any number, but I'm choosing 0 because it makes my calculation easy. Okay, so y equal to 0, so I plug it in. So that means 2x plus 5 times 0 equal to 20, which means x equal to 10. So I have identified another point called 10, 0, and this point is also on this line. So up to this point, I have identified these 2 points on this line. So now I can plot them and connect them. So I have my ruler here. When you graphically plot lines or anything, you better want to make sure you have pretty accurate lines and marks. So this is x, this is y. First of all, every mark here represents 1. Okay, that's the scale I choose. First point is 0, 4. So 0, 4. This is 0, 4. Second point, 10, 0. So let 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is 10, 10, 0. Alright, so now let me connect these two points. Okay, here we go. So this is the line called 2x plus 5y equal to 20. That's it. So I have the first task completed. Now move on to second task. Similarly, just another line. I need to plot this line. So all I need to do is to find 2 points on this line and connect them. So I'm going to start off by setting, say, x equal to 1. Again, this is totally arbitrary. You can choose something else. X equal to 1. Now plug x equal to 1 to this line. So I got 3 times 1 minus 2y equal to 11, which is the same as 3 minus 2y equal to 11, which is the same as 2y equal to minus 8, which is the same as telling me y is minus 4. So I identify the first point, which is called 1 minus 4. Good. Now I need another point. This time I'm going to set y equal to, say, minus 1. Okay. And by the way, you see I choose for both lines, I first choose a value for x and then another value for y, a value for x, another value for y. Okay, this is totally, this is just a coincidence. Okay, you don't necessarily need to do that. Okay, you can choose x and then another x or y or another y. Doesn't really matter. Okay, plug this into the equation. So 3x minus 2 times minus 1 equal to 11. You simplify it, it's the same as 3x equal to 9, which is the same as x equal to 3, which means x, y equal to, okay, 3 minus 1. So I have the second point. Okay, now I can plot those, identify those points and connect them. First point is 1 minus 4, 1 minus 4, 1, 2, 3, 4, so it's over here. 1 minus 4. Second point, 3 minus 1. So this is 3 minus 1. All right, connect them. So here's a line called 3x minus 2y equal to 11. Okay, so we can visually identify the intersection is over here. But you cannot just look at the graph and see, oh, and say, oh, wow, it looks like it's 5, 2. No, you cannot do that. Okay, you will not get any point in the exam if you do this. You need to solve the equation to identify the coordinate of this intersection. So that comes to the task number 3. To identify this intersection, that means we're trying to find x and y such that they satisfy both of the equations. Okay, this point needs to be on this line and also on this line. So that means this point needs to satisfy both of the equations simultaneously. In other words, all we need to do is to solve this system of two equations with two unknowns. Okay, so the rest is algebra. There are many ways to solve this. I'm presenting one of the ways. So I'm going to call this equation 1. I'm going to call this equation 2 just for ease of reference. My strategy is to cancel x so I can find the value of y. I'm going to do that by first multiplying first equation by 3. So I got 6 over here. And then multiplying the second equation by 2. So I also get 6 here, so they can cancel out. So multiplying first equation by 3, I get 6x plus 15y equal to 60. Okay, it's still the same thing, same line as equation 1. I'm going to multiply equation 2 by 2, so I get 6x minus 4y equal to 22. Call it equation 4. So now you see I got 6x in both equations. Okay, 3 and 4, remember, they are identical to equation 1 and 2. They are the same thing. But now with the 6x over here, I can cancel out x. What I'm going to do is subtract equation 4 from equation 3. So 3 minus 4, that gives me 19y equal to 38, which is equivalent to y equal to 2. Good. So now I know y is 2. Now let me plug it back to either of the equations. Let's say equation 2. So I got 3x minus 2y, 2 times 2 equal to 11, which is the same as 3x equal to 15, which is x equal to 5. Okay, good. So I identify the solution, which is the intersection with a coordinate 5, 2. Okay, so indeed this is 5, 2. That's it. So this is how you graphically solve for intersection for this kind of problem.